Good afternoon. We're going to begin chapter 10 today. This chapter is all about circles. This is a lot more in detailed calculations and formulas than what you've learned in the past. So let's begin. So here I have a circle. Okay, and again, this is in your textbook. If you can follow along your textbook, their visuals are a little bit better than mine because I'm doing mine by hand. Here's a circle, and we have some new terminology for you to understand or to learn. Okay, we'll start with the center. Here's the center of the circle. We call this circle P. If you were to write it down, you would write it like this. You know how we do like angle? You know how we do like angle M? We use this symbol for angle. Well, the circle symbol is a circle with a dot in it. So circle P would be like that. So that means circle P. Okay, anyways. Here we have an angle. This is angle APB. We call this a central angle because this angle is based in the center of the circle, so it's called a central angle. The central angle is always going to be less than 180. This angle out here is called a complementary angle, I think, or a corresponding angle. I don't remember which, but just know that this angle it's supplementary. It's not supplementary. It's the rest of 360 degrees from this angle. All right, anyways, this is called a central angle. This central angle has something called an arc. An arc is the curve on the edge of the circle that corresponds with this angle built with these two radii. Okay, this is an arc. We call this the minor arc because it's less than 180 degrees. And the corresponding one would be this red one here. This is called a major arc because it is more than 180 degrees. So this one is less than 180 degrees. It's called a minor arc. And this one is greater than 180 degrees. It's called a major arc. Let's see, what am I missing here? Okay, so this is see this little arc over top of AB? That's the symbol for arc. So just like we have a symbol for angle, we have a symbol now for circle. This is and if we were saying line AB, it would be a line over AB, but arc AB is a little arc over AB. And here we have arc ACB. Whenever you have an angle that goes through another point here, you list all three letters. So the reason I don't have to list arc AB is because, the reason there's no third letter in there is because, one, it's a minor arc. This is, you only have to list two letters if it's a minor arc. And if I said arc AB, it would be tough to know whether I was talking about AB this way or AB this way. If it's a big arc, list that other letter. So this would be arc ACB. Okay. All right, there's two other things we need to know, and that is the space here, like a slice of pizza. This is called a sector. It's just like a slice of pizza. And then this is called a segment. If you draw the sector and then you draw a chord from this point here to this point here, this green space is called a segment. All right. Any questions so far? Okay, perfect. All right, so we're gonna be doing a few things. We're gonna be finding angle measures. We're gonna be finding areas. And we're also going to be discovering the difference between degrees and radians. Okay, let's start with degrees and radians because I feel like that's what really confuses me as a student. And I'm not great with radians. I'm going to start off by saying I am not good at converting degrees to radians, but I'm adequate. So let's do this. Let's start out with this. How many degrees is this angle? I'm waiting. 90. Thank you. This is a 90-degree angle. Okay. If I labeled this A, B, and some random point on this circle other than A and B, we'll call that C. Okay? What is the name of this angle? We would say the measure of angle what equals 90 degrees. P, I'm sorry. P is the center. Not AB. It would be the measure of angle APB. Right? Okay. Isn't this angle here look similar to this one here? Well, it is. These are called congruent. We would say the measure of arc AB is also 90 degrees. So if this is 90 degrees here and this is 90 degrees here, we can say these two things are congruent. All right. So I want you to write this down, or you don't have to, but we would say that angle APB is congruent to arc AB in degrees. Okay? That's the first thing that we need to learn today, is that a central angle is congruent to the what is the word? In something with an I. Hold on, let me look it up. Where are you? Intercepted. Okay, so that's a new term for you. This arc intercepts this angle because they share the same radii. This radius and this radius form this angle. These two radius also form this arc. So this angle will be congruent to this angle. The measure of this degrees is equal to this degrees, okay? Now, this angle here is also congruent to ACB, to arc ACB, okay? So if this was, so this is what, 270? Yeah. So that means this arc here, from here to here, is also 270. Does that make sense? Okay, so the first thing we're going to learn is a central angle is congruent to its arc. Now I'm going to change what I'm teaching you here, and that's we're going to talk about degrees and radians. So how many degrees is this angle? We'll call it angle APB. It's 90 degrees. There's another measure for angles. There's two ways we can measure an angle. We can measure an angle in degrees, and there's another measure which we call radians. Now, radians is kind of confusing. and it's based on the radius, which is why it's called radians, okay? So here's my radius. All right, so I'm gonna give you the conversion up front so that you just, and if you don't need to know how we get this. All right, I'm gonna explain it a little bit, but I'm not gonna go into detail because it's too much information, all right? Here's the formula. Theta equals n times pi over 180 degrees. All right. Now that doesn't make much sense because you don't know what theta and n mean. Theta is representing the measure in radians. So, how many radians is this angle? That would be represented by theta, okay? N represents the measure of the angle in degrees. Okay, so this particular formula can be used to find radians given degrees. So if I tell you 90 degrees is the angle, you can tell me how many radians it is. All right. So to do that, you just plug 90 in for n, and you solve this, and you'll have how many radians. So let's do that for this angle. 90 goes in for n, and theta equals 90 times pi over 180, which is 1/4 pi, 1/2 pi. So this is 90 degrees or 1/2 pi radians. Radians we like to leave in terms of pi. We don't like to actually multiply it by pi's decimal expansion, okay? Okay, let me ask you this question. What percent of the circle is 90 degrees? Good, 25%. So what percent of the circle would be 180 degrees? Okay, good, 50. All right, so if 25% of the circle is a half radian, or half pi radian, how much is 180 degrees? Pi, or 1 pi radians. So 90 degrees is 1/2 pi radians. 180 is 1 pi radians. So what would be a whole circle? Two pi. Good. If you can remember that a whole circle, 360 degrees, is 2 pi radians, that'll help you in the future, okay? And we're going to come back to this. All right, so in your notes or whatever you're doing, the thing here to remember, the two things to remember are that a whole circle is equal to 2 pi radians. So 360 degrees equals 2 pi radians. All right. The other thing is this formula here, that radians equals degrees times pi over 180. So remember those two things. And we're going to come back to this because we're going to use this as conversion in some of our problems, okay? I'm going to write the formulas up top so we can follow along later. So theta equals n times pi over 180. If you want to shorten that, it could just be theta equals n pi over 180 is fine. All right, so there's one formula. Okay. All right. So now let's jump into some of these problems. Okay, here's our first problem. And this one, they're real short. What is the measure of XP? Does anybody know? 86, good. How do we know that, Charlie? We know that this arc here is equal to its central angle. Okay. So what is the measure of XLP? So I don't know, it might be 274, Charlie, but let's be clear. How do you find this? You subtract this arc from 360, right? So it would be XP, 360 minus XP. And Charlie, you're telling me that's what? 274, right? Charlie, did you use a calculator for that? All right, so I'm assuming that you're right, but I'm not checking it, but hopefully it is. 360 minus 86 is 274. That's what Charlie says. Okay, you checked. Good, perfect. Okay, any questions here? Okay, now, what if I also did this? What does this tell me? This tells me that XL is congruent to what? To LP or PL, either way, yeah. So these two are congruent. So what would be the measure of XL? And don't tell me the number, tell me how I would find that. So here's how you would find it. Well, we do the same thing we did above. We would say that this is equal to 360 minus XLP. I'm sorry, XP. So to find the measure of XLP, we would subtract this from 360, right? That will give me this. And then I need to divide that in 2 to get this, right? Because they're congruent. Does that make sense? So 274 divided by 2 is 137? Now, what should all of these arcs add up to be? 360. Good. All right, moving on. All right. Now we're going to talk about arc length. Okay. So let's say we have a circle, and the central angle of that circle is 102 degrees, and the radius is 5 feet. So it's a big circle. All right. What is the length of arc AB? Well, you don't know because I haven't told you how to do it yet. Here's how it goes. Does anyone think they understand how you might find that arc length? All right, well, for sake of time here, let's just go ahead and talk about it. Basically, what you're going to do is, we know that this angle here is out of how many degrees? (360). So this is the part, this is the total degrees of the circle. Part, circle. Part's on the numerator, circle's on the denominator. Total's on the denominator. All right. We also know that AB is part of the arc, or is part of what total? Circle P, right? Yeah. Okay. So the circumference of circle P. So this is a part of the whole circumference, where this angle is part of the whole circle. So that's basically how we're going to do it. We're going to set it up as a proportion. We're going to set it up as the central angle to the total degrees, and we're going to set that equal to the arc we're looking for to the total circumference. And we're going to solve. So we don't know what AB is. That's what we're looking for. But can we find the circumference of P? Yes. What is the circumference of P? If you remember, circumference is equal to 2 pi r. So this is 2 pi 5. Now we have a proportion we can solve. Just ignore the degree symbols. We have cross multiply, or you could solve it a different way, but I'm going to cross multiply. This is 102 times 2 times pi times 5 equals 360 times, and I'm going to call this AB, I'm going to call it S. So an unknown arc measure, or arc length, we call S. S is the symbol we use. I don't know why, but it's what we use, or it's what the book uses. Okay. So the length of AB, arc AB, is equal to S. And here we're going to solve for S, and we have to do some calculations. Let me go ahead and do those. 102 times 2 times pi times 5 equals, and we're going to divide that by 360, 8.9. So S is approximately 8.9 feet. Because again, we're looking for the arc. We're looking for the arc length. Okay, this is circumference and length. That's how you find an arc measure, or an arc length. Any questions? So if arc AB is 8.9 feet, well, how much is the other part of this? Well, I'd have to find the circumference and then subtract 8.9, and that would give me the rest of it. Or I could use the same setup, but I would use, instead of 102 degrees, I would use 258. Yeah, 258, and then I plug that in instead of 102. Guys, I'm not getting any feedback. How are we doing? Are you guys getting this? Does this make sense? Okay, good. I'm getting yeses. Okay, perfect. Thank you, Charlie. Thank you, Devin, Eddie, Christina. All right. Now, there's a faster way to do this, and that is this formula. I'm going to give you another formula. You don't have to have this memorized because I just showed you how to do it without the formula. But there is a formula using this information. It's basically this setup, but it pre-solves it for us. The formula is S equals N over 360 times 2 pi r. Okay, now we could have just plugged 102 in for N, and that would have done all this, and it would have, which is basically what we did. Didn't I multiply 120 times 2 times pi times r and then divide it by 360? That's what I did, right? Yeah. Okay, so that's the formula. Let me write this. This is radians degrees. This is circumference. This is arc length in degrees. Now I'm going to show you, what if you wanted to know how many radians? I'm sorry. This is arc length if you're given degrees, okay? So N is for degrees. Let me write that there. Now, sometimes you might get a circle and they won't tell you it's 102 degrees. They might tell you it's blank radians. You need to be able to do the same thing, but in radians. Here's the formula for if it's in radians. And it's actually pretty simple. S equals theta times R. And this is for arc length in radians. And this theta means radians. Okay. Okay. You're going to have a problem on your homework that looks almost exactly like this. And it's asking us, if we have a circle with a radius of 100 meters and a central arc, or our central angle of 2.25 radians, how long is the arc? So let me draw the circle. And this is not drawn to scale. I don't know the answer to this yet. So it could be, my angle is going to be totally off. So the arc is 2.25 radians and the radius is 100 meters. So the question is, how long is AB? Okay, so you have a few options here. You could use this formula here, which would be very fast, super fast. Or you could convert 2.25 radians into degrees and then use this formula here. Okay, I'm going to do it both ways. I'm going to do the hard way first, and then I'm going to show you the quick way, which is this one. All right, so let's assume you're just not comfortable with radians. You don't like them. You want to change it to degrees. So we're going to use the conversion, theta equals n times pi over 180, to convert it to degrees, and then we will find out the arc length. Okay, so this is the long way. First, I have to convert 2.25 radians into degrees. I'm going to use this formula up here, theta. Okay. What is theta? What number represents theta? Good, 2.25. What number represents n? We don't know. N is a variable. It's how many degrees. It's what we're looking for. Leave it as n. Pi 180. Solve this for n. Start by multiplying both sides by 180. These cancel, and we're left with pi n pi equals whatever 180 times 225 is. $405. Then we divide by pi. And here's what you're going to not want to do. You want to leave it in terms of pi. So these cancel. We got n equals 405 over pi degrees. Okay? Which is, if you divide that, 405 divided by pi is about 129 degrees. So this is approximately 129 degrees. Okay. So now that we have it in degrees, we can use that to find out how many, what's the arc length. So I'm going to erase this. So now that we know it's 129 degrees, or 405 over pi, 2.25 rad equals 405 over pi degrees. Okay, that's what we just found. Okay, so now I'm going to use this formula because I have degrees now. And I'm going to use it. You know what? Let's just say it's 129. Okay? Let's just leave it like that. We could put it in terms of pi, but I'm going to confuse you if I do that. All right, so let's use the formula. S equals n over 360 times 2 pi over r. And the rate, and we know what n and r are now, so S equals 129 over 360 times 2 times pi times 100. And I'm going to do the math. 129 times 2 times pi times 100. That's a big number, about 81,000 something. And we're going to divide that by 360. And we get 225.14. So S is 225.14. 0.15, if you round correctly. Meters. All right. Now, that was the long way. Here's the short way. Short way is we have radians, 2.25, and I have the formula that uses radians, so I'm going to use that. S equals theta times R. S equals 2.25 times 100. S equals 225. This is actually more accurate than the other one because we didn't approximate pi. But 225 is close to 225.15, right? Okay, so this is the fast way, that's the long way. Again, these two formulas find the same thing, but one uses degrees, one uses radians. Any questions? No. There's actually a third way to do this, and that's to set it up as a proportion. No, never mind, ignore me. Yeah, ignore me. Okay, let's do, so I've got those, I've got all that. All right, so we have two more things to learn, and then we are finished. And these things are pretty simple-ish. So I'm going to erase these formulas because I don't think I need them. I don't need these formulas anymore, okay? So I'm going to erase them. Okay, so we have found angles in degrees and radians. We have found arc lengths. Now we're going to find the area of segments, of sectors. Remember, a sector is like a slice of pizza. So we're finding the area of this shaded region here. And the only thing we know is the radius is, let's say, 9 inches. Okay, so how do we find the area of that space? Well, oh, I'm sorry. We also know the angle measure. Okay, so there's two ways to solve this. There's setting it up as a proportion, which I'm going to show you first, and then I'm going to give you the formula so you can use that later, okay? So here's the proportion. We know that 120 degrees is the part of what hole? 360 degrees. Correct? So what percentage is that slice of pizza from the whole pizza? So how do you calculate that? Well, you divide. You divide 125 by 360. And actually, that's going to give us a decimal. It's about 33%. It's close to a third. It's not a third. It's close to a third. So I'm just going to simplify the fraction, okay? Let's make it 120 so that it's easier. Sorry, let's do that. 120 divided by 360. This will work with any number, but... I'm sorry, 360 divided by 120. So that's 30%. Wait. It's a third. It's 33%. Okay. So this space is 1/3 of the total space. So basically, if we can find the area of the total space and then multiply it by 1/3, we will find the area of just that space. Does that make sense? So I'm going to find the area of this whole circle and then find 1/3 of that, and then I'll find the area of this black space. So how do you find the area of a whole circle? Well, area is pi r squared. In this case, r is 9, so it's 81 pi. Leave pi as a symbol because we're going to be using it in another calculation. Well, it depends on what the program asks you. It might say leave it in terms of pi, which would be that, or it would say round it to the nearest whatever. So you would have to do that. Do not use 3.14. Please use the button pi on the calculator. Otherwise, you might get the wrong decimal. Okay? That's the area of the whole circle, right? So now I need to find the area of just this space, black space. So I need to find 1/3 of 81 pi. Well, what's 1/3 of 81? .27 pi. So the area of this space is 27 pi. Inches squared, because that's area. Okay, now here's the formula. It is n over 360 times pi r squared. And remember, n is the degrees. And if they give you the degree, if they give you the angle in radians, you'd have to change it to degrees first and then use it. Okay? All right. We're making good time, actually. Okay. So there's another area we have to do. Oh, if we use this formula for this problem, it would be area equals 120 divided by 360 times pi times 9 squared, and you would end up with 27 pi. Same thing. Okay, there's another area you need to be able to find, and that is the area of a segment. So this space here is called a sector. If I draw a line from the end of this to the end of this is called a chord. The space above that chord is called a sector. Now, to find the area of this sector, here's what you're going to do. First, you need to find the area of this segment, which is all of this space. And then we're going to subtract out the area of this triangle. So, here is the beginning of the, well, here's the formula. Area of sector, or segment, equals area of sector minus area of triangle. Okay, now let's put some dimensions on this. Let's say that this was 6 millimeters. And let's say that this angle is, let's go with 80 degrees. Okay. So in order to find the area of all that blue space, of the black space, we need to find the area of the blue space and subtract the area of the red space. So, let's first find the area of the blue space, which is the whole sector. So remember, from what we just did a minute ago, the area of the sector is n over 360 times pi r squared. And we know the area of a triangle is base times height divided by 2. So these are the two calculations we have to do. So let's do this blue one first. I'm going to need to erase, okay? Just remember, 80 degrees and 6 millimeters. Let me redraw this. Okay. First, we need to find the area of the sector. In this case, it's 80 over 360 times pi times 6 squared. So I'm going to do that calculation off screen. 80 divided by 360 times pi times 6 times 6. 25.13. It's approximate. Okay. Now I need to find the area of the triangle. And the area of the triangle is where this gets into what we learned a long time ago. Alright? Here's the triangle. If I know this is 6, what is this side here? It's also 6, because these are both radii of the same triangle, of the same circle. So this is 6, the other radius is also 6, which makes this an isosceles triangle, which means that this is equal to this, okay? We can use what we learned in the past. What is this angle here? It's 80 degrees, right? So what is just this angle here? $40. Which makes this 40. We know these are 90, which makes 90 and 40 is 130, which means that needs to be 50 and 50. Now, we need to find the area of this triangle, so we need to know the base and the height, right? So we know the hypotenuse of each right triangle, but we don't know the base or the height. But we can use our trig ratios to find the base and the height because these are right triangles. So that's what we're going to do. The sine of 50 is equal to the opposite over hypotenuse. And that'll tell me what the height is, right? If I want to find the base, I need to do the cosine of 50. Cosine of 50 equals the, we'll call this b for base, over 6. Now let's call this, yeah, let's call this b for base, but I want to make it look like a b. So those are my two ratios. Now I can find out what the base and the height of this triangle are. All right. I need to use my calculator here. You know what? I can use this one. Okay, so the sine of 50 is 0.76 or 0.77. And then if we multiply that by 6, we get 4.6. And the base is the cosine of 50. And then we multiply that by 6. And we get 3.9. So which means that this is a height of 4.6 and this base is 3.9. So what is the area of this triangle? It's the whole base times the height divided by 2, or it's just, yeah. So we need to do 3.9 times 2 because we need the whole base. So that is 7.8. Times the height divided by 2. So area equals base times height divided by 2, which is 7.8 times 4.6 divided by 2. 7.8 times 4.6 divided by 2. So the area is about 17.9. Now, this number will always be less than this number because the space is smaller. The red space is smaller than the blue space, right? Okay. So now I'm ready for my area. Area of the segment is, in this case, 25.13 minus 17.9, which is equal to 7.23 inches or millimeters squared. Okay. I'm going to rehash out what I did. Okay? The only things I knew were the radius and the angle measure. To find the area of the sector, you need to find the area of the segment and subtract out the area of this triangle. So I need to find the area of this pizza slice and subtract out the cheese. Think of the sector as the crust. To find the crust, I need to find the whole pizza, the whole slice, and subtract out the cheese. All right? So I found the area of the whole slice using the area of the sector formula we just learned. And that's where I got 25.13, using this formula. Okay? Then I had to find the area of the triangle. For that, you have to use a little bit of math. And because I didn't know the hypotenuse and I didn't know the base length, I needed to use the interior angles and the trig ratios to find these two side lengths. Okay? So I did that and I found this to be about 3.9 and this to be about 4.6. I rounded to the nearest 10th or 100th, I don't remember. Anyways, I found those two things here. And then then I needed to double this one because I needed the whole base. That's where I got 7.8. 7.8 is 3.9 times 2. Okay. Did 7.8 times 4.6. I divide that by 2 because that's how I find the area of a triangle. And I got 17.9. Anyways, once you find those two numbers, subtract them, and you'll end up with the area of the crust, which we call the sector. All right, that's a lot, and I'm not done. I got one more thing. How are we doing so far? Give me some feedback. Is this making sense what I'm doing? The good news is if you get confused, watch the video on this part and see where I go, what steps I did, okay? One more question, and the only reason I'm doing this one is because it is one of your homework questions, and it's good that I show you. I think you guys could figure this out without me showing you, but I'm going to show you anyways, because it is a little confusing. Okay, we have a clock. And the question is, this is number 9 on your homework, on assignment 1. Well, it's similar to number 9. It's not the exact same thing. Through how many radians does the minute hand of a clock rotate from 9 to 9:25? From how many radians does the clock minute hand rotate from 9 o'clock p.m. to 9:25 p.m. So we're going from 9 o'clock to 9 o'clock to 9:25. And we're only looking at the minute hand. We're not looking at the hour hand. Okay. So there might be another way to do this type of problem, but here's how I figured it out and the way I seem to enjoy doing it. The first thing you need to do is you need to break down each minute into radians. So you need to write a ratio. We need to figure out, we know there's 360 degrees in a circle, and we know there's 60 minutes in an hour. So we know there's 60 minutes in an hour, and that is represented with 360 degrees in the circle, okay? I'm sorry. Yeah, 360. Okay, now, remember what I said at the very beginning of class. 360 degrees is how many radians? Not 2, close. 2 what? 2 pi. Okay. So 60 minutes is 360 degrees. 360 is 2 pi, right? So 60 minutes is to 2 pi. So 1 full rotation of a circle is 2 pi radians. Okay. Now, 60 minutes over 2 pi. How much is 1 minute? So how do I find out how much 1 minute is? Well, I need to make the numerator 1, which means I basically need to divide by 60 on the denominator, right? So here's what I did. Now, if this is confusing, flip everything upside down. Put the big number on top. That's fine. You could make 360 up there or 2 pi up there. It doesn't matter. Anyways, 1 minute. So I'm dividing this by 60, and I got 1. So if I divide this by 60, I get, what is 2 divided by 60? (1/30). Okay, does that confuse you? Do you see how I did that? I'm basically reducing the fraction. I'm finding the unit rate. I want to know what 1 minute is. So if I go from 60 minutes to 1 minute, that means I divided by 60. But I have to do the same thing on the numerator and the denominator. So if you divide 2 pi by 60, you end up with 1/30 pi, or just pi over 30. Okay, so here it is. We know every minute is pi over 30 radians. How many minutes passed on the clock? We went from 9 to 9:25. How many minutes went by? 25 minutes. Okay. So 25 minutes went by. So how many radians went by? So if 1 minute is this, well, what is 25 minutes? Multiply it by 25. And you get 25 minutes is 25 pi over 30 radians. So the question says, how many radians does the clock minute hand rotate from 9 p.m. to 9:25? It rotates 25 over 30 is the same thing as 5/6 pi. 5/6 pi radians. Okay, now, there is a shorter way to do this, but I wanted to show you exactly all my conversions here. Okay, here's the shorter way. Shorter way. 60 minutes is how many radians? Two pi. Well, how much is 25 minutes? Is how many radians? Cross multiply and divide. 2 pi times 25 would be 50 pi, and then divide by 60, which is the same thing as 5/6 pi. That's shorter. Okay? That's it. Thank you guys for hanging out a little bit extra time. Appreciate it. It was about an hour, a little bit more. Good luck. Godspeed. I'm available every day from 9 to 1, so if you need help, email me and we'll set up a time to meet, okay? All right, bye, kids.